So welcome, I'm George Mavridis. I am tech journalist at 4i Magazine, and I'm also responsible for the social media. And 4i Magazine, October is Cybersecurity Awareness Month, and 4i Magazine has prepared 3 free webinars where we're about to discuss cybersecurity issues with great people like you two guys. And we will start today discussing the cost of poor API protection and common pitfalls discussion. And we have with us Neil Weitzel, who is Security Operation Manager at TradeX, and Kristi Shehu. So welcome guys. Thank you for joining us today, and I hope we will have a great discussion.
Thanks, George. Happy to be here.
Same here.
Well, let me just introduce you to our audience, and then we can start our conversation. Well, Neil has 15 years of experience working in various roles, from user support to leading security program, and he has profound experience in security architecture and cybersecurity best practices, which help him provide valuable insight to security teams. Before TradeX, Neil worked with organizations such as Cognizant as an application security architect, or Citadel as their practice director of vulnerability assessment, and EIQ Networks as their director of security research. He also served as a cybersecurity instructor and delivered numerous securities and defense programming courses to various clients, such as NASA and PayPal. And he is an active member of the security community and has delivered lectures at DEF CON and local security meetups. Neil also acts as an adjunct lecturer in software engineering at his alma mater, Indiana University, and we are really happy to have him today with us. So welcome, Neil.
Thanks. Thank you. Happy to be here. Yeah.
We are really looking to hear your insights to our topic. And we also have with us Kristi Shehu. Kristi is a cybersecurity engineer profiled in web application security, currently based in Albania, working for one of the largest companies handling projects for national government, financial industry, and so on. And she has transitioned from her early career in digital marketing and content creation to working as a cybersecurity engineer and also as a cyber journalist for 4i Mag. And now she has dedicated her time and career towards application security engineering and creating content to raise awareness for different cyber security risks. Welcome, Kristi, as well.
Thank you, George, for your presentation. Thank you, and happy to be here.
Yeah. We are about to discuss, as I said before, the cost of poor API protection and common pitfalls discussion. So my first question for you guys is, why is API protection necessary for the future? Neil, you can actually start and give us your perspective.
Sure, absolutely. So, the prevalence of APIs is continuing to grow. They really do give us a certain flexibility by nature. APIs, they allow us to really change the front end of our applications or have other systems and machines interact with our APIs. And we can just keep the business logic in a lot of cases very static, or just make updates to that independently of what we're doing on the front end. And because we're seeing the evolution of the development kind of moving that direction, so we have that type of flexibility, their prevalence is becoming more. We're seeing more APIs and more interactions in that space. And with more prevalence, attackers are going to be attacking them more or targeting them more for their attacks. So that's why, it's really imperative that, as we move forward, that, we focus on API security. We ensure that we follow our best practices and that we harden them, to the fullest extent that we can. that's kind of the cusp of why API security is so hot right now.
Yeah.
Kristi, what do you think?
Well, actually, I totally agree with Neil. And I think not only me, but every security professional working in this field totally agrees that the API protection should be focused more and should be like the primary, one of the most crucial parts where we're talking about risk assessments, basically. And as Neil said, businesses are using API and much more nowadays, and they are trying to optimize the performances, their workflow performances, of course, by using API connections. And it's a common knowledge, basically, that APIs are used by businesses to connect services and to transfer data back and forth in order to optimize the business's workflow, to raise efficiency, etc. But as Neil said, at the same time, we're also raising the level of risks. And that's why it is very necessary to have specific strategic plans in order to conduct a fully proper risk assessment when we're talking about APIs. And the risks that we're talking here are enormous, actually, and we can see them in everyday life as well. But I think we can cover this with our talk, because we had the previous conversation with Neil and we were discussing something actually that happened to me a little while ago, but it's a very common vulnerability that happens, and perhaps we can discuss it later on during this webinar.
Yeah, definitely. We will elaborate. So, Kristi, what is all the buzz about zero trust? Because there is a lot of discussion about zero trust nowadays.
Yeah, zero trust architecture or approach is basically the hot topic, the trend of the moment. And actually, it has existed way long ago. But the thing is, right now, I can see Neil nodding as we discussed. But right now, it's become like the trend that everyone keeps talking. Basically, what does zero trust mean? Zero trust architecture, it says trust no one, no user, no device. And basically, this kind of approach arose, let's say, even more after the whole global pandemic situation that happened. And since everyone started working remotely, the need to have such approach or methodology architecture implemented into everyday's life or businesses, procedures, workflows, it became necessary. But the question is, what do we do with the zero trust architecture and how we can implement it in order to prevent risk from happening or to further leverage the security plans or strategic plans in order to protect APIs? And basically, I think it's, as we said, APIs are used to connect services and transfer data. And as we also said, businesses are using more and more APIs nowadays. But if we can see it in the terms of users, actually, APIs can be seen as, metaphorically speaking, always, user, let's say, a non-human user, like machines communicating to each other, but systems communicating to each other. But at the same time, the whole concept of the zero trust architecture can also be implemented into API protection and security by basically creating different plans or methodologies where you can erase or just say make the least privileged access to APIs, to control, to monitor the access on APIs in order to prevent risks from happening, and also to keep an eye, if we can put it this way, to raise the level of security in API protection. I think perhaps Neil can add a little bit more into it since he has a lot more experience.
Certainly, yeah. You definitely hit like on one of the cusps of the topic, right? And that's this idea of zero trust has been around for a while, but you said like least privilege access. And that's really kind of what we're going back towards, because that concept around zero trust and least privilege access has been around for quite some time. And it's, even embedded into a lot of our security frameworks, as well as policies and procedures across a lot of companies, and as well as frameworks that are used for things like PCI or FDIC and things like that. So this whole idea of, okay, what does that really mean though, is, implicitly deny everything. So we want to make sure that any time in a case of an API, if we're going to access something, all right, what are the least common things that we can have in terms of access? Maybe that is a particular geographic region. Maybe that can be an entire country, a city, a state, things like that, where we can say only these particular individuals should access it. We can do it based off of time as well. Like, oh, well, we only expect someone to access this API at 8 a.m. when they log in, or at 8 a.m. when they process all of the payment processes from the previous day or something like that. So I mean, we can think about it in that scope, but we can also think about it in terms of users and systems that you alluded to. So maybe only these systems that we already know and trust should interact with this API, or maybe only these particular users that have access to an application. So that kind of goes back to like, all right, when we're building these applications or APIs, how do we deny implicitly everything? So we need to make sure that every single time we perform an action or make a connection or things like that, that we're actually doing an authentication and authorization check. We want to make sure, like, okay, is this person actually permitted to do this? Is it within the confines that we expect them to be within? Like we talked about earlier in terms of like geographic region or time and things like that. And I think that kind of like, really is the cusp of what we need in terms of zero trust, and especially in the context of, API security.
So, Neil, could you actually share with us some best practices, maybe tools, or I don't know, methods of testing API protection?
Absolutely. Yeah. Because, a lot of times we're, in the realm of APIs, we're looking at things and we're saying that these are, supposed to be machine to machine interactions. So we have a lot of assumptions that kind of come into play there, where we kind of expect the machine's going to do exactly what we think. And we have expectations of how that's going to interact with our APIs. So then when we're starting to think about like, okay, well, what does that mean from testing in an abuse case, right? Like, what are the worst case scenarios that someone could have if they exploited this API? How might somebody actually abuse it beyond what we just say is a use case? Maybe if we're supposed to use this to look up information, how do we make sure that it's only scoped to the information that we intend each person to do? And so we need, like you said, like tools and methodology to understand, like, how we're going to do that. There are, a whole arsenal of tools. Some of my favorites, I use Burp Suite quite frequently, Zed Attack Proxy or Zap. Those are ones that I use on the regular basis. And I usually use those in conjunction with something like Postman. Like a lot of times, like these are kind of like, you'll set up like Postman, you'll proxy it through something like Burp, and then you'll have that interact with the API backend. And the reason why I kind of use these things in tangent from one another, or kind of like in line one another, is like I can upload a schema or like a known idea of what this particular API is supposed to be doing, or what it's documented to do. And then I can use something like a proxy or Burp or Zed Attack Proxy to make edits to it, in line, like do what call like a little fuzzing. So like if this is supposed to be like an integer, maybe, I'll say like, okay, I'm going to try to put some characters in there, see some payloads of, cross-site scripting, SQL injection, see if I can actually, get the application to accept those, or maybe even re-represent those to me later in the use of that application. So like those are kind of how I approach it. Similarly, like when you have an idea of like what you need to test, that helps a lot. And, I come up with this concept is like, we try to think of like abuse cases, and that will be something that we can honestly use to say like, all right, if we back into these are the worst case scenarios of an application, we can say like, okay, so how do we write abuse cases for that later? I'm sure Kristi has some experience in that as well.
Yeah, Kristi, could you share your approach with us?
Actually, about the abuse cases that Neil was talking about a little bit earlier, we were having a discussion, and unfortunately, I was dealing with some similar case actually. Since let's give just a little bit of example. Recently, I was trying to test something, an API, to do an API security testing, and the thing is that the abuse case that Neil was talking about actually was missing. And me as a tester, I did not know if I should see the proper parameter, let's say, or the module behind. So I didn't have the information if the things that I were seeing at that specific moment, I should be seeing that or I should not be seeing that. So basically the whole case was missing, the whole information for me, it was not clear. And at the end of the day, me as a tester, I thought that everything was okay. Everything was supposed to be as it should be. But the thing is that with the case that is missing, the information is missing from me, this may lead me to believe that actually I'm seeing something that is correct. But at the same time, the thing that I'm seeing right now that I exposed through actually, I use burp actually by getting the request, the thing that I was supposed to be seeing, I should not be seeing. So it's all about the information that you get. You have a complete clear view of what you should be seeing or not, and to conduct the further tests and the risk assessments.
Absolutely, yeah. Just to kind of like that's so common, as a tester or even like an application developer, because an application developer will see like, okay, here are the list of these use cases or user stories that I need to implement as features, and they're kind of very focused on, okay, let's make sure that these execute on my test parameters as I intend them to, right? But then, on the security side of things, you're not always sure if these features are that you're seeing, like, hey, you're only supposed to see, access to client A's data or client B's data if if there's supposed to be cross-pollination. And so if we don't write up these abuse cases, then you're kind of, these things can actually make it into the end product. And so that's kind of why, like you're saying here, like that happens probably more frequently than we want to admit. But, the more that we can kind of like back into these ideas, right? These are our use cases and abuse cases, we can test and verify them. And, so many times where I'm testing, I run into the same situations where I'm like, well, I wonder if they intended that or not. And there are times where I write them up as, vulnerabilities in like the report. And it's like, oh no, we intended that. And then, but then, you always have the one that you did that you didn't write up, and it's like, oh, well, wait, I should have. So it really helps to define that like up front.
Yes, unfortunately, it's very common. I think it's very common to everyone. It does not depend on the place where you are located, or it's just a global problem, I think, where we're talking about this type of risk assessment, if we can put it this way. So basically,
yeah, I think it goes back to the the assumptions we make, right? We just have these assumptions of especially in the API space, like I was saying, like machine to machine interaction. We think that, okay, somebody programmed this machine, so it's of course not going to abuse my API. Yeah. But in the end, once an attacker sees how this works, once an attacker sees that there's actually information that might be of value to somebody there, then of course that those abuse cases start to leak in.
I couldn't agree more.
So let's talk about organizations more, organization security. I want to ask Neil, what do you think, how are developers leveraging APIs in their environment, and how does this affect an organization security? What's your insight on this?
So, I mean, developers leveraging them themselves. I mean, I think that they're probably developing more of them, and they may not be like leveraging them as much, like more internally, just because maybe on like their normal applications. But again, like that's an API developed by somebody else again. So I mean, really with developers, I think they're just leveraging APIs kind of the same as normal users, but probably developing more of them. And with that, they're becoming more exposed, more widely used. And so we should really kind of, I take this as the opportunity to kind of back in and say, like, we should really make sure that they're taking into account every step of the SDLC, our secure software development lifecycle. And so like we have, the steps of the secure development lifecycle of, building the requirements, designing, how this should interact from a system architectural level, and then developing the code, testing it, QA, and then the deployment. But each one of these stages of the software development lifecycle also has a corresponding point within the secure development lifecycle. So in terms of the requirements, we know that we want to do a risk assessment. So like, we might say, hey, we want to create this application to perform this business logic. Well, what is the risk inherently, not just in the application itself, but the data that could be manipulated or misused, abused again? If it got exposed, if it got edited, things along those lines, if it were, if the availability of that data just wasn't there. In the design phases, when we're looking at, how the whole infrastructure and how the whole application is going to work, in kind of between like the database and the back end and the API, as well as the front end. We need to do a design review, or what we call like a threat modeling, where we think of, okay, what are each one of the steps within our whole environment that a bad actor might try to exploit. On the front end, that's somebody trying to attack the application from the outside. But we have to consider, similarly, somebody leveraging code that has vulnerabilities in it. So a lot of times when we're developing code, we leverage third-party libraries. And if we leverage third-party libraries with vulnerable code in it, how are we ensuring that that doesn't make it into the end product, or at least that we're developing around it in such a way that we've hardened it, and so that we're not, vulnerable to it. Similarly, physical security comes into scope in threat modeling. The next step is, the deployment or the development stages, where we're actually like cutting the code, writing the code as a developer, and in that stage, the secure development lifecycle, you want to do static analysis. So, there are tools that can help with this that plug into IDEs, so that you can, hey, I just put in cross-site scripting by accident. So it can tell you like, hey, don't do that. Make sure that you're using parameterized queries, or make sure that you're, casting this to a variable before you actually run this SQL statement, for example. But the other piece of that is that those particular tools can kind of be noisy in terms of false positives, as well as the configuration of your particular environment can be really tedious to get those tools to be effective. So I always say that there's no real replacement for like partner code reviews, because those are the folks who know your code the best, right? Like, hey, I wrote this new thing. Can you check it and make sure that I didn't do something, nefarious unintentionally, like, by, implementing, SQL injection or a race condition, things of that nature. And then once we have, the risk from the upfront, the requirements and risk assessment phases, we can look at the testing, right? So like when somebody's doing the QA, how does this actually run in a runtime environment? Does it meet all of the use cases we want? We can also look at it from the security side. Is did we, put in the right hardening to ensure that we didn't fall trapped to any of the abuse cases or those worst case scenarios that we came up with earlier? Or, make sure that we didn't inherently introduce new risk to the company. So, and then the last point is always the deployment of this product. And that's kind of where security can, create a feedback loop back to the beginning of the SDLC. So, when you're deploying something, we want to bring into the case monitoring. And that can be done in a lot of different ways. So monitoring not just like how the application is working in normal procedures, so that when we can like adjust notifications and paging, that'll tell us when we're outside those normal like baselines and things like that. But similarly, we can put other, security tools in place, like a web application firewall, which could in the end protect you from new vulnerabilities that come out, or provide you time while you go through another iteration of your SDLC. So a new vulnerability comes out, a new bug is introduced into the wild, and your application is vulnerable to it. Well, if you have something like that in place, you can go ahead and block that type of exploit at the edge while you go ahead and implement proper remediation guidance in the actual code itself. All right, so that was a lot. I'm sure I missed something there.
Well, Kristi, what do you think?
The thing is, I totally agree with Neil on how the whole procedure should follow the workflow of it. But the thing is, we have to be quite honest, actually, from my point of view and your perspective. From the whole stages that Neil described, the development stages, static analysis or code review, and the testing, security testing, and the monitoring, they're okay, people do it. But one thing that they always miss, and I've seen this from above, is the threat modeling, the design review, and the risk assessment. Actually, that's a flaw that I'm seeing everywhere, basically, because the risk assessment, it's not done at proper beginning, and often it gets overlooked by. And the thing is, people should really know what's, as Neil described, what's risky to the business and what can go wrong if a wrong case scenario happens, and what can go wrong and the impact of it, and just create a complete design review, like a complete strategy to do the threat modeling and the design review of the whole application, let's say, to have a clear view, the full visibility of all the APIs, in order to better understand what we're going to do later on, the code review, security testing, etc., and then later on the monitoring, so we can implement everything, every single stage as it should. So basically, from all the stages, we're starting from the middle to the end, and then starting again from the beginning. So we have to get every single stage in the right order in order to raise better efficiency towards security API protection, basically to raise security to a bigger level.
100% right. Like you hit the nail on the head there, because so frequently we look at security as an afterthought. We make the product first, and then we go, oh wait, we need to make it secure. Exactly. And so a lot of times we end up like with something that's already produced at the end, and then we're like, okay, now we need to go test it. And that's kind of like you're saying, like because of that, we end up missing a lot of the risks up front in the design review. And so that's this whole idea that I'm sure other people have heard this of, let's shift left, because the more we shift left on the SDLC, we get some of those things in. And that's why security has to have like a front seat, or like a first class citizenship at the development table. Because if we're doing it always at the end, the big cost there is we find something that is a huge security vulnerability in the runtime. Like once the product's already been developed, okay, now we have to go back and redevelop the product, and that's time, effort, money that's just spent. So it's very costly. But if we address these things up front, like you're saying, at the shift left point, we can actually have a lot of assurance that by the time we get to the end of the SDLC, we're looking at a very hardened product and maybe only having to do a few tweaks here and there.
Yeah, exactly. And the thing is, this is very common, unfortunately, because if it was supposed to be as it should be, from point A to point B, every single stage in the right order, everything, the cost would reduce majorly, the efficiency would be much better, and of course, the level of security would be much higher. But unfortunately, we are trying to work towards that direction, and that's why we're having like webinars and discussions like this in order to spread the word and to tell people how it should be, actually.
So I think that you have actually covered a lot of things about what can an organization lose by having poor API security. So Neil, I just want to ask you, how do tools interact with APIs, and how does this impact different roles and responsibilities within DevScopes?
Oh goodness. So yeah, I mean, really to effectively do API security, like any good project or security in general, we have to look at it as like a team effort, like a project, and each person on the team is going to have different tools or different responsibilities that kind of come together to build this good ecosystem that is secure, right? I mean, from I think across again the SDLC, or like all the stakeholders and making a product or an application, from product management, developer, the people who are doing the QA testing, the people who make the systems that are running the application, like your systems engineers, and then the leadership, right? So each one of these stakeholders has a lot to offer, from the product manager, who should be understanding the risk of what the data is that they're operating with, again, when they're making the user stories, feature requests. Well, what are the abuse cases? What are the things that could happen, like in the most dire situations, so that we're taking that again at the design and implementation phase. And then of course the developers, if they understand the abuse cases, and they can read them alongside their feature requests, they can develop the code in such a way that's going to take that inherently into the development concepts of writing their application. So it's like, oh, well, okay, I need to make sure I'm doing an authentication and authorization check like right here along the way. And so then if they're doing that like with the development, we're going to have a harder product, and it's going to be easier then for the QA testers in the next step to say, all right, hey, what are my tools here that I can use? Maybe they start using some of the things that we talked about, like Burp and Postman, in order to say like, all right, am I seeing any new vulnerabilities come in here? Am I being able to validate that all the abuse cases that the product manager wrote have been validated as closed and not inherently introducing risk to the company? And then, of course, it makes it easier for the systems engineers to say, all right, well, if the code's really good at that point, then I can now focus on how somebody accesses the application, how these pieces interact with one another between like the API and the backend database, or other pieces of business logic. How are we carving out our VLANs to make sure that only certain systems can talk to each other, making sure that the processes that run these applications run in the right user space versus under administrative privileges or under system privileges that then could be exploited later on. They can focus on their scope there, and they can use a lot of like access control level tools to validate that similarly. And then, with the leadership needs to enable each one of these roles. Right. They need to make sure that they culturally, as well as like process wise, enable people to keep security like in their purview and in their responsibility across their whole, kind of role. So, alongside their normal features and, responsibilities, they need to do it with a secure manner. And the best way I find to, empower people to do that is to give them access to security practitioners, give them access to folks who have, the knowledge, experience, who can help them, test and validate or think about things from the abuse case perspective, things like that. So, each one of these is going to have like a little bit of different, responsibility, but together they make like a very good, strong team. And everybody has to kind of mature and help each other together. Otherwise, like any team, you're only as strong as your weakest link.
Exactly. And as Neil said, and I totally agree, it's not only the responsibility of the security engineer in order to create a complete plan of protection for APIs, but it's also the responsibility of everyone's basically, because we're talking about APIs, we're not only talking about public APIs, but also internal APIs. And we have to say, because also Neil mentioned it before about attacks, and hackers are not after the basic injections anymore. They're after logic flaws. And the thing is, the logic flaws are a consequence of actions, and that can be coming from different people, actually, different professions, different roles inside the company. That's why this whole idea of API protection should be implemented on the different roles, and people should be more aware on what they can do and the whole process of development, how to make it more secure and safer. So we hope by doing this kind of presentation or webinar, we're trying to affect some of the points, or just showing how we can raise a little bit of awareness. But at the end of the day, it's also not only our work, as Neil said, but everyone's work and responsibility. We just have to share the knowledge with other people to spread the word and perhaps try to make the environment more safe, hopefully to make it more safer. So.
Yeah, that's right, Kristi. We should really spread the knowledge. So I would like to ask from the participants if they have any question or something to ask or to add, they can use the chat. And as I'm going to leave some minutes for that, I want you guys to summarize the whole discussion here with a short sentence about the importance of API protection and the cost of having a poor API protection. So Neil, just want you to, summarize our discussion and give us the main ideas here.
Yeah, sure. I mean, in general, don't forget about your APIs. They're just as important as any other application, any other piece of like your whole security ecosystem. And to forget about them could cause the same dramatic effects as any type of exploit against your company or product. Nobody wants to have to deal with that recovery of the brand degradation or the exploit of your company's information out in the wild. So I mean, those are just some of the most dramatic things. So again, yeah, APIs need to have like the same importance level as any one of your other applications.
What about you, Kristi?
Couldn't agree more. We should have like a specific plan for risk assessment and for API protection, honestly, because the impacts of it are enormous if we leave APIs exposed or unprotected. Basically, we can handle with data loss, the loss of credibility, losing in costs and whatever. Everything is possible if we leave this behind. And the thing is, we should enforce as security engineers, and not only the idea of creating secure plans and strategic plans in order to integrate them inside business everyday procedures or application development life cycles. It's a must, in our opinion, and of course, it's crucial since today that we are talking, businesses are using more and more APIs, businesses, companies, users, and everything. So we have to be extra more careful about this.
Yeah, definitely. So I see that we don't have any questions. Actually, you have covered, I think, all the topics really in depth. So I would like to thank you both for today's discussions. Our webinar will be recorded, is being recorded, and we are gonna publish it online. So feel free whenever you watch it to send us an email, to text us, I don't know, to use our social media platforms. If you have any question or anything else to discuss with us, I really like to thank Neil for his participation, and Kristi, you too. So thank you both, and I wish you good luck and take care of your API protection.
Thank you.
Thank you.
Yeah, definitely. I appreciate the call out. This is definitely an area that's near and dear to me. I love collaborating in this space. So yeah, if there's ever a question, or if you just want to, chat about security in general, I'm always, open ears and love, having those types of conversations. Yeah.
We can also share our personal information, for example, our email addresses, if anyone is interested to know more or just to get a little bit more information, to keep in touch and create a network. Perhaps we can be the new team of API protection, that community that will help each other grow more.
The API defenders.
Definitely. Great. Thank you, guys. Thank you all. Thank you all for watching our conversation. And once again, you can always chat us and text us whatever you have as a comment, or maybe something you want us to come up with a follow-up meeting and discuss it. Thank you.